All right.
I guess I'll
So
provide the introduction. Yeah, so
hit it.
we're working on this AI agents project, which if anybody's familiar with like custom GPTs, the stuff that OpenAI is working on, uh, essentially the same functionality is what we're looking to provide. So in our world, an agent consists of basically three things: a system prompt, um, a LLM provider backend that system prompt is tailored towards, and then a set of tools that are available. That's like the nomenclature in the LLM space is tools, or I think OpenAI maybe refers to them as like function calls. But essentially, whenever the LLM needs to that's what an agent is, right? It's an LLM that can interface with the real world in some way. So whether that's because it needs to fetch data or context that it wasn't trained on, or like precise information, or it needs to perform some action on behalf of the user. These are the sorts of activities that they delegate to external function calls. When we were starting to think about how we might do this, we basically like have two options, and one is similar to like how they've begun to implement actions in Duo, which is to just like hard code them into the application, right? So Duo can do a finite set of things. I don't know exactly what off the top of my head, but it can interface with merge requests somehow. It can like um, summarize issue descriptions. Like there's various like connection points that we've made with GitLab internals that allow the Duo agent to perform certain behaviors or fetch data. Um, when it comes to like custom agents, though, we can't really like we can't hard code into the application every function that a user might want to expose to their agent to perform some arbitrary task, right? Like if you're creating an agent to manage like your Salesforce leads or something like that, right? There's no world where it makes sense for us to hard code that into the Ruby monolith, right? Like that sort of behavior. And so we were left with two options: either develop our own ecosystem of like shareable tools and Python code or whatever, that like agents can be loaded with, or leverage something else in the platform. And I think leveraging something else in the platform is obviously favorable because we don't want to be building multiple ecosystems um, of functions, if you will. And so I started to look at StepRunner to see if it might fit the bill, and I think it does, because when you boil it down, every step is just a function, right? It has discrete inputs, it has discrete outputs, and that's really all that is needed for an LLM to know what functions it can call, what it needs to pass it, and what it gets back, so that it can potentially stitch multiple together or just formulate the final response to the user, right? So I did some experimentation just to see if it was viable at all, and I was actually shocked by how good the results are with how little effort I had to put into it. The examples are at the bottom of this README that Joe is sharing, and I think they're pretty cool. Like they're pretty interesting. And so what I want to do now is figure out like what gaps exist between like where StepRunner is today and what we would need to like have a production implementation behind the agents, and what me and the rest of incubation engineering might be able to do to contribute to that effort in a way that doesn't get in your way or get in the way of runner integration, which I know is a priority.
Cool. Thanks for that. Thanks for that intro. Actually, it was really nice to hear the larger context of what you're working on. Um,
And I think
and
like when I try to
mm,
explain this to folks, sorry, I'll
mm,
let you take it away from here. But when I try to explain this to folks, I want to be clear that it like I think when people look at this project, they think, oh, LLM generated build configs, like that makes sense as a use case. But I want to be clear that yeah, that's a great use case. And I think if we become good at generating build configs, that's like broadly applicable to like, you know, like helping you write your CI templates. But I want to be clear that we're talking about leveraging Step Runner in a way where the agents actually evaluate the steps too. Like they don't just do the code generation, but they actually evaluate it to get a result to feed into like the chat context, right? So it's like I ought to be able to ask an agent a question like, what's the weather like where this GitLab user lives, right? And it not just generate the code that's necessary to answer that question, but actually give me the answer too, right?
Yeah, and I think that's the part that I didn't get when we were talking before. So
Oh,
that's a
okay, cool.
really, yeah, yeah. I mean, as a matter of fact, what you're talking about is using Step Runner entirely out of the runner context, like as a
Mm-hmm.
totally separate tool. And that's actually exactly the kind of thing we were hoping to enable, unexpected uses of Step Runner, because for it to be helpful as a for it to be helpful as a programming language and an environment, you need to be able to take it out of the context of CI, use it locally, use it different places. We've also, looked at using it as part of events, event for event processing. So this is a really
Yeah.
actually a great use case to drive sort of like those principles of having it be its own self-contained project. So that's great. That's super great. I kind of wanted to just talk through some of the asks. So to just sort of give you some context on which of these things we're thinking about and where they're at in our roadmap.
Okay.
Yeah.
Cool.
So gRPC service is actually this is actually pretty core to the recursive abstraction of Step Runner. There's two places that we're going to be using this server in two different contexts. One, of course, is to get the job, or that is the steps, the list of steps in the initial environment to Step Runner. So the runner integration is the first place to use the gRPC server. And one of our engineers has spent the last couple of weeks, Axel has spent the last couple of weeks doing a proof of concept for this. So he actually got this working just to sort of like see how it feels to wire it into the runner. There's two merge sort of POC merge requests here. This is the runner side, like what is it like to shim this into executors and stuff. This is all kind of like taking a new thing and bolting it onto an old thing.
Mm-hmm.
The other side is in Step Runner and just sort of shows what kind of changes we need, which are not really that many. It's actually
Mm-hmm.
not that big of a change. Most of the conversation though is in this merge request. So I wanted to link this, and we'll include this in the video description so people can find it. A lot of the conversation about like what the behavior should be for the gRPC service is here.
And I missed the first point you described, like two similar but different use cases for the gRPC server. Can you
And
just
I just
reiterate
gave you the
those?
first one, but I didn't give you the second one
Oh,
yet.
okay. Well, I must
Yeah.
have misheard.
The second one
And
is,
and
oh
can you
God.
clarify for me, like
Mhm.
architecturally, where does the gRPC server sit? Like, is it spun up by the um within the image that the job is being executed in, or is it sitting
Yes.
like alongside the runner?
The step runner itself is embedded in the execution environment. And this is a big change, right? For runner, it means no longer do we need to sort of orchestrate things remotely, like in a micromanaging way through shell scripts. We just need to find a way to get the payload into the environment and it will run itself and allows us to also reconnect.
Okay.
So runner is going to have a client and there's going to be a service which is running inside of the execution environment. Now, this could be an ephemeral VM, and the
Mm-hmm.
service might start up. We might use it once and then throw it away. But for self-managed or self-hosted runners, or even our internal runners that we reuse, it might be servicing multiple jobs,
Okay.
concurrently. So there's like a daemon process that exists or will exist on the VM itself or the execution environment. The way we get it in there, we're still going to drive everything through SSH because that's our authentication mechanism. That's how everything works. But we're going to SSH into the machine, and then we're going to kick off a proxy that just connects us to a Unix socket. This is what we do already for the nesting service for running um, uh, virtual machines inside Macs. So we sort of have an agent in the dedicated hosts, and we spin up and down up to 2 virtual machines. So we're familiar with this mechanism. But really, at the end of the day, it's just a gRPC service. You could serve it over a port. You could serve it over a Unix socket.
I guess like it touches on like a pretty foundational change to how we think about like the execution environment of jobs, right? Because we're talking about going from I guess being like container centric regarding the execution environment to being VM centric, where like we need to now define like a baseline virtual machine image that all
I wouldn't
jobs are expected
necessarily
to.
say so. I wouldn't necessarily say so. That actually, I mean, the second use case is kind of where I wanted to bring in containers.
Okay.
We're always going to need VMs. We're always going to need containers. We just have such a wide set of use cases in Runner. Me and Camille have played around with a lot of different ways of containerizing jobs, running things in a pod or a container or something. We've settled on the solution of fully delegating into a container. So what we'll actually do is, say you have a VM, running, and you want to run your job in a container, or you want to run a single step in a container. We will have a step that knows how to do that. And what that step is going to do is it's actually going to take the actual steps that you want to run as an input. And it will start the container, and it will either have step runner inside the container, a second step runner inside the container, or it will inject it and use the gRPC service to hand those steps to that step runner. So it's the same mechanism that runner uses to inject steps and run them in a VM. A VM can use to run them in a container.
Okay.
So gRPC is just a way of making of taking a piece of your result graph and the step execution, doing it remotely, and then getting it back and stitching it into the larger set of results. We want it to look exactly the same, because then it also lets you do stuff like nested virtualization. Like maybe we want to run big Linux machines and run jobs inside of nested VMs. We've experimented with that a little bit. Then VMs are the same deal. You just need a step that specializes in starting nested VMs and knows how to hand off the job to the step runner that's inside.
And I guess like what's nice about the abstraction is that you don't even really have to care like whether it is a properly nested virtual environment or just remote execution of any kind, right? Like you could have a virtual machine that is like where the first step doesn't create a nested VM, but just launches another EC2 instance or something.
Sure.
Like another,
Yeah.
right?
Yeah, I think
Describing
describing it as like remote execution is probably the better way. Yeah, it's just remote execution of some sort. As a matter of fact, Runner could and Runner could actually take those steps and do them in parallel across multiple machines. And then bring the results together as long, if you specify a parallel type and you know how dependencies.
The one thing that sort of surprised me about what you said, one thing I didn't expect to hear was that like nested step execution would require like instrumentation within like if you're delegating to like Docker to evaluate something within a container, I would have expected that to just be like a built-in behavior of step runner, where it wouldn't like need to spin that up and instrument it to get another instance of step runner that it could communicate with. I would have expected it to just like treat that at the same level of abstraction as like a shell script, right? Where it's like, I don't really care, because you almost can't, right? Like how do you generically like inject a step runner binary for the right architecture and whatnot into that image, make sure that it is like the entry point, and then sort of shoehorn whatever the entry point was to be the step that gets you know what I'm saying? It seems like it seems hard to do.
Injecting step runner into an environment. Is that what you're describing? Like putting step runner into a VM or putting it into a container.
Yeah, like I totally get like if you are launching VMs that have step runner installed and they expose
Hmm.
gRPC interface, and then you're off to the races, right? You can do anything in that environment once that's set up. But
Hmm.
when it comes to like nested execution, that sounds a lot harder to take an arbitrary Docker image with its predefined entry point that I want to evaluate. How do you have step runner orchestrate that and also instrument itself? You know what I mean?
Well, I
Because
think
I think
that
that
there
gets
are
tricky.
still a lot of unanswered questions in this space. Like this is going to be like an area. This is an area of complexity. We have done some things around this, like injecting um, dumb init into a container from into one container from another. There's definitely a lot of like weird specific edge casey kind of things. But in general, I think that when you want to run steps in a container, you don't necessarily replacing the startup command would be reasonable because you don't want to run it in this other thing. You just want to have an environment in which to run the steps. Like maybe
Mm-hmm.
you want to run steps in Node.js, but you don't have Node.js or Lua. I mean, like I've been using Lua as like a proof of concept because nobody scripts in Lua in CI.
Mm-hmm.
And so it's not installed anywhere. And so if you want to, write your script in Lua, you need a thing that knows how to spin up and it knows how to put stuff in put a script in a Lua environment. And then, so you just put step runner inside of a Lua container, and then it will run this Lua script for you.
Mm-hmm.
Um,
Mm-hmm.
so I suspect that a lot of the containers will, replacing the entry point isn't going to be that big of a deal. Um, but it will be there'll be specialized use cases like putting it in a VM. Some people are going to want something different, which is one of the reasons why we wanted to take that mechanism and make it a step itself. So you can put your own injection mechanism into a step. Even Docker run itself
Mm-hmm.
is a step. It's not built into steps. We initially started with steps running Docker containers, but
Mm-hmm.
we pulled that out of the core because, where does it end? You want to run VMs, you want to run this, you want to run that. It's a lot. We really want people to be able to take a containerized remote execution injection mechanism and stick it in there. Maybe we even have one that falls back to just running commands remotely, like the
Mm-hmm.
way the runner does now without step runner. But it's totally up to that step how it gets the job done.
Okay. And I guess like I was it's you only need that instrumentation when you want to do nested
Mm-hmm.
step evaluation.
Mm-hmm.
But
Mm-hmm.
in a sort of nominal typical use case of like I just have some off the shelf Docker image that
Mm-hmm.
I know does what I need,
Mm-hmm.
that can just be a top level step, right? And then in that case, step runner doesn't need to instrument that container. It can just evaluate it, right? I guess it doesn't
Hmm.
matter. Like it's not an implementation detail of step runner because to your point, like the doing a Docker run is itself a step, and you can implement
Hmm.
that however you want,
Hmm.
sort of a thing.
Hmm. I think so. I think so. Yeah. Yeah, like in our SaaS Linux runners, we as part of, setting up the job execution environment, we run Docker, because the user specifies an image,
Hmm.
and inside that image is the execution environment that they want.
Hmm.
So we can do things outside of that, like binding in step runner as a volume or something too. But yeah, this I don't have all the answers definitely in this space, but Aaron Walker's been thinking about it quite a bit. Camille's been thinking about it quite a bit. Right now, our tech is sort of like assume that step runner's inside of there. If you want to run steps in a container, just put step runner in there. It's a
Hmm.
Golang binary, so it's pretty self-contained, and we can compile it for all our architectures.
Yeah, that makes sense. Yeah.
Mm.
Yeah.
Actually, the whole like uh, remote execution containerization as a step is relevant also to a question that you had about languages. Um, I'm going to jump around here a little bit. You were saying that you kind of want to have a native scripting engine. And we've talked a little bit about expressions because there is some level of scripting or language that needs to be part of the core of StepRunner in order to do things like conditional evaluation and manipulating some of the core data as inputs and outputs. However, when it comes to actually scripting in a language, like I was saying about Lua, we don't actually need to include that in um, the expression language. We don't need to include that in the core because running something in Lua is just a matter of running the Lua step and giving it as input a list of steps. This is why we had the like arbitrarily structured inputs. So you can give it like a list of steps and some deeper structure.
Uh, I'm. Do you have an example that you could pull up quickly
Yeah,
just to give me a
let's see
visual
here.
on that?
This is the older version of Step Runner before I rewrote it. Rewrote it a couple of times and pairing things away. Let me see if I have an example here. So here's a step. This step is the Lua, run to something in Lua, right?
Hmm.
And it just has one input, which is a script. And it takes that script and it just execs Lua,
Hmm.
and that's it. And so, oops. I think in here there's a unit test. Is there a unit test? I want to find it where it looks like to call Lua. Oh yeah, here we go. So here's a case where we want to run something. Oh, in this case, I want to run this Lua script inside of a Lua container. So the first thing I did is I used the Docker step, right, which knows how to run a Docker container. And I gave it the image and I gave it the inputs. And everything inside of here um, to the outer step runner is a single value, right?
Hmm.
It's just an opaque blob. So it starts up this Lua container and then it starts up the step runner inside and hands it these steps, right?
Hmm.
Says, hey, here you go. Here's a step to run. And that inner step runner then picks up and says, oh, hey, you want to run a Lua step? Great. So it downloads the Lua step and it gives it the input, which is script. And then that script evaluates print hello steppy.
Hmm.
And then it collects the outputs. Does that make sense?
Yeah, that makes total sense. I think the I guess in terms of like developing best practices around this stuff, like this seems like a relatively complex solution. Like when,
Yeah.
when
Yeah.
I
Yeah.
when I look at how like and this goes back to like definition of like a best practice in environment that is the true host of Step Runner, right? Because like what I see on GitHub Actions is like rather than like spinning up a Docker image to execute Node, right? That they just kind of assume that Node.js is installed on the host machine in some cases, or like they have installer steps that install binaries on the host machine and then make sure that the paths are set up to where they're available to subsequent steps. And um, I think there's trade-offs, right? Because like on one hand, it's a bit odd to have like implicit dependencies between otherwise fully decoupled steps, right? Like if I have a Node.js step that allows me to execute like say it takes a script input and allows me to execute that JavaScript, right? Um, the fact that like you'd have to run install Node.js before that is kind of weird, right? Like there's an implicit dependency there. So if you only use the evaluate script or evaluate step and you don't have that Node.js runtime dependency, it's going to fail, and that's annoying. And there's, as far as I know, in GitHub Actions, no way to declare those implicit dependencies, right? Like I
Yeah.
don't think they perform some check to make sure that the environment is set up properly to evaluate that step, right?
Yeah, yeah. Actions just sort of like bakes in Node as the default. So to get away with not doing that, there's a second data model that we're going to be creating, which we've called the sugared data model. And that data model is going to lean towards making it easy and convenient and not verbose.
Mm-hmm.
Okay. And you're going to be able to do things like, you should be able here. Really, all I want to say is at the top level, I just want to say, maybe script Lua or, runtime Lua, and
Right.
then give the script. I don't want to do all this. Like, I don't care how you get Lua. So we're going to have a translation from this sugared syntax to this core syntax.
Mm-hmm.
Because what I have shown here is a very, very small amount of syntax, and it's defined in a protobuf. So it's that core long-lived, backwards compatible,
The expanded definition,
the
basically.
expanded definition, the
Yeah.
compiled, like thing that will run. Um, and so actually the very next task that I'm going to do with steps is create a second data model. And this one is going to be defined by a JSON schema, because
Mm-hmm.
that JSON schema is going to be shared between Rails and StepRunner. Because Rails wants to be able to validate what you type in the UI as well. You want to be able to sort of check the steps. We can be a little more wishy-washy about like how, backwards compatibility and stuff as we go. It's not like you're naming the protobuf fields. The only requirement is whatever we make in that syntax has to fold or expand to this core syntax.
Mm-hmm.
So we're going to make a lot of decisions around like when you say runtime Lua, how do we want to expand that? And we can change it too. So maybe like runtime Lua will actually expand to install Lua, run this command.
Mm-hmm.
Or maybe it will expand to Docker run the Lua container with this script. But that should be something that we can change.
Yeah.
So yeah, you're absolutely right. This is very painful and very verbose. And actually, the steps that you will author as an AI will probably be the more verbose, the sugared ones. Like, what would be best actually for an AI to learn to do?
It's hard to say. I suspect
Guess
it
you could do
probably
both.
doesn't matter. Yeah.
Yeah, because you could hand like Step Runner can take both. The only
Yeah.
if you get if it give it a proto buff blob, it just will skip the expansion phase. I mean,
Yeah. And I think the
all the
LLM
same.
is going to generate whatever, like, it doesn't really care. It's going to generate whatever it's been provided examples for,
Mm-hmm.
right? So like if you've provided the sugared syntax, it's going to it's going to give you back sugared syntax, right?
I kind of feel like that would be the better one to go with because at some point you may want to take what the AI generated and then sort of like adopt it and manipulate it manually or feed it back in.
I
And
agree. Yeah.
so that's the one.
And
I've
I think
also
it is simpler, so it's simpler to provide examples for, and ideally, like the LLM generates whatever like the user would want,
Mhm.
because yeah, I think there's a variety of reasons why that's valuable. But getting back to like the the scripting engine like use case, I guess. Um, I I think there are good reasons to have like a native interface that has zero dependencies.
Mhm.
And I think the obvious one is expression interpolation, right? Like we have to have something that fits that bill. And I think that's like it's easy to have a custom implementation there with very tight expression syntax that doesn't have a lot of built-ins, and um,
Mhm.
it is very simple, just like dot notation or using the pipe operator or what have you. It'd be
Mhm.
easy for us to like build that natively, and I think we would build that natively. Um, but as we're making that decision, I think we should also think about like possible relation to that sugared syntax, where like you have say runtime riser, or even just maybe that is what like script is, right? If you don't specify a step or anything and you just specify script, right? um what does that do, right? And what dependencies does it carry, and what would we need to install at runtime? And at least in our case of AI agents, like this thing has to be super fast, right? So ideally we're generating step definitions that have zero dependencies in most cases. If we need to do something complex, it's worth it to have to pull that in so that we can evaluate a complex task or perform a complex action. But I would I think that the vast majority of like operations that we would expect agents to perform can be modeled like almost entirely. Well, I mean, if you just scroll down to the examples that I've done so far,
Mhm.
right? Like I'm using the Go GitLab SDK, but I think these are fairly representative examples of like the types of things that the LLM might need to reach out to GitLab for, right? Um, and like the render markdown one is probably the best example. This is making an external call to GitLab to render that markdown, right? But everything I've done here is a pretty simple like Go script, right? I mean, Go's not a scripting language, but it's fairly straightforward operation, right? Bit of string manipulation, bit of markdown rendering, like, but does not require a full Go runtime, right? Like, prob is I would argue the sort of thing that like should maybe be able to happen natively for the sake of performance, right? Because I actually implemented this, and if you um I have a step in this repository called like GitLab script or something, because I wanted to actually wire it up, and so this injects um the like script input and like just creates a Go program to evaluate
I like
that,
it.
right? but it has to be compiled, right?
Yeah,
And before it can be evaluated. And it'd be nice if that didn't need to happen. You know, if we could just like natively make an HTTP call, natively make a call to the GitLab API, that sort of stuff.
yeah.
Natively
I have
render
a,
Markdown.
I have a few thoughts on that. For like the aesthetic of the tool, having being able to take the expression syntax and then use the larger version of that also for your scripting feels really nice, right? Like
Yeah.
it feels natural. So you only learn one language instead of
Mm-hmm.
two. So if we only target the expression language, we probably won't get a really nice larger scripting language too that you
Right.
can. I mean, you could always sort of say, like have a step that runs the expression language, but it's not going to be missing a lot of stuff.
Mm-hmm.
Um,
And
yeah,
I do at the same time think that like we should probably put some guardrails on what is allowed in interpolation versus what is allowed in the full script block, right?
mhm,
Because
mhm.
in terms of like the um like I haven't thought this through, so I'm just speaking off the top of my head, but it intuitively seems like it would be very difficult to perform static analysis if you were performing like an HTTP call in an interpolated expression, right? Like you probably don't want to let people do that because like all bets are off in terms of like what happens at runtime at that point, right? Like no longer is something defined by squarely by its inputs and outputs. It's like you've
Yeah,
got
yeah.
stuff happening in the expressions of
Yeah, I
and
agree. I think the expression language subset needs to be quite simple and easy to understand. Um,
and just
yeah,
static, I guess, right? Like it shouldn't
hmm
have side effects.
Yeah, it should be functional.
Mm-hmm.
Um, yeah, and I've also like considered as far as like compilation performance and like evaluating things like Go. For the eventing space, I was considering having the ability to execute WebAssembly payloads.
Mm-hmm.
So you can compile a lot of these Go scripts and whatever, actually just have a general, like whatever scripting you want to target WebAssembly with. You can compile them ahead of time and cache them and evaluate them faster than
Yeah,
shelling out.
yeah.
Um, yeah.
Do you
Yeah.
have much experience with that? Because like that was I reached to that initially, like when I was
Mm,
looking for projects like Riser and what our options might be. Um,
yeah.
and it seemed like I always hit a wall with like seemingly obvious stuff like making network calls, right? It seems like it's so hard to provide like a robust WASM like runtime that is capable of doing that sort of thing, let alone like actually like in the user land compilation of everything to WASM. Yeah, I don't think any of that is part of WASM. I think it's part of something called like WASI or something. But yeah, it seems complicated.
Yeah, I was just trying to pull up the results that I had. Yeah, it was a couple of months ago. I did some prototyping to get binary data in and out of a WebAssembly runtime. And I was able to make it work, like it's painful with just WebAssembly.
Mm-hmm.
Um WASI is better supported in the last like 6 months in the primary and then like the standard Go runtime. I was also using TinyGo, which had really good WASI support. Um, you can inject an API as well. Like I was considering like sort of taking the GitLab API and injecting a pre-authenticated client set of functions into a WebAssembly runtime. And so you sort of just you compile against an interface, and just with the promise that these functions will be there. And then when you spin up the WebAssembly, you take you authenticate a client with the job token, and you bind that into the runtime environment, and it works. It works. I've gotten bytes in and out. The reason I was thinking about WebAssembly was sort of again for this ability for people to do surprising things and to find a nice boundary of responsibility. It's like the new Docker container kind of boundary, like it's a nice thing to be able to say, we just run a Docker container because everyone knows what you can do inside there and you have a lot of flexibility.
Mhm.
Um, but yeah, to your point about performance, in theory, Step Runner will be caching steps, and steps that do things like install a runtime can also cache their work. But it's a lot more complex, and it's a lot easier to lose control of that performance. Yeah, I think this is something we should seriously consider. We should chat with Camille about if we want to just even if we don't want to provide something like Rise or scripting from the get-go, if we use that as an expression language, then we have the
Yeah.
ability to sort of we have a whole language that's also very nicely, clearly this.
Yeah. Yeah.
Um,
That's what I was thinking too. Like it provides a path forward and it's not like I think the riser syntax seemed to be fairly unopinionated. I was in the process of
mhm.
making a comment on that uh expression MR that you linked me to. So I'll take that as an action to follow up on.
Cool. Yeah. Yeah.
And I
Another
think like
poss
the, the other thing I was thinking about is just like when you um like when we I think what is special and super helpful about like step runner outputs is that they can be like highly structured and semi-structured and it seems like we aim to support like complex objects as output, right? And I
Actually, I
think
wasn't. I was targeting just strings.
is that like when I was talking to Camille, he said it was strings now, but that we might do
No,
complex
he
objects
has
in the
plans.
future. Is
Okay,
that well? So I,
maybe.
I think there's value there, right? Like I mean,
Mm,
like um, if I make an API call to GitLab to get like a user profile, right?
mhm.
Nice to be able to shove that into an output as a JSON string, but have it parsed out on the other side automatically. But regardless of like, I think the point I'm about to make is almost more valid if we only support string outputs. Um, if I have a JSON string as an output of one step, and I
Mhm.
need like structured data as the input to the next step, do I want to be doing a bunch of JSON
Nah,
manipulation
yeah.
like within
Yeah.
an expression, right? It's nice to be able
Mhm.
to drop into a full script block, have Lambda functions where I can do like dot each and then iterate over the whole array,
Mhm, mhm,
pluck out
mhm,
attributes
mhm.
that I need, formulate it
Yeah.
into like something that makes sense. And then,
Yeah, I think you're right. I think you're right. I think we'll probably end up with structured outputs, or maybe like the subsequent two steps grab different pieces of that output. And they
mhm,
want to do that with just a path.
yeah.
Um, yeah,
But I
I
think
was most,
having that
mhm.
plumbing step in between where there's
That's
like
annoying. Yeah.
I think it's like I don't find it annoying, and LLMs certainly don't either, right? Like one point I was making here is that like it the LLM knows it needs the location information out of the user
Hmm.
profile, right?
Hmm.
But like, what step would it use to extract that and then pass it into the next thing, right?
I was sort of thinking that you wouldn't necessarily want to have a repeated step that parses JSON just to make it available as a complex input or to pull it out. I don't know. Anyway,
I
but
think yeah, sorry. I think it depends, right?
mhm,
Because like it's not just that we would talk to the GitLab API or just that we would talk to any API, right? It's like lots of APIs suck and they return like non-ideal responses, right? Like
mhm,
imagine that I need to like I perform some search query and I want to pluck some result out of that, right?
mhm,
I'm gonna
mhm,
have to loop over the array. I'm gonna have to find which one
mhm,
I'm looking for based on some properties in that thing, find the one I
mhm,
want, and then maybe do string manipulation on the property that I care about to
mhm.
then pass it into my weather AP step API. You know what I mean? Um,
Yeah, yeah, I think you're right about the complex structured outputs. And there's really nothing stopping us from doing this, like just other than trying to minimize the scope. And you could fold it into the context and read it. And maybe even like you could have like a pre and post sort of processing script that you could attach to the output so you don't even have to make it a separate step.
Yeah, yeah.
Yeah, that's a good point. Yeah, we can go there. That would be fine. Another thing I wanted to point out was like your ideal error messages,
Hmm.
um, and just say this is would be great. I love that it's the machines want the same things that the humans do. Like,
Finally, we're in that day and age, right?
yeah, like Jagarash was playing with this and he was like, I got an error and I had no idea what it was because there's like all this stuff that's like from the internal implementation. This is what I want. Like, error is as good as rust,
Yeah, yeah.
where it says
And,
you made a mistake here.
yeah, and I think there's a lot of complexity behind this ask. I think this is going to be really hard to do because you have to like very intelligently interface with your YAML parser, right? And then you have to be able to like then output YAML that is annotated. Um, so uh,
It's
yeah,
especially complex with the sugar to core transformation,
yeah, yeah. Oh
because
yeah,
it
yeah,
has to
yeah.
be able to bridge that gap as well.
Hmm.
But I think it's tremendously worthwhile. So there's a tremendous amount of value here for everybody to be
And
able to.
maybe to provide some context around the ask because it's
Hmm.
fairly nuanced. It's like, have you played around with like OpenAI's code
I
interpreter at
haven't.
all?
Yeah, no, I haven't.
Okay, so it's really cool because like sometimes it writes Python code to answer your question correctly, but sometimes it writes garbage code that can't even be evaluated, right? But what's interesting about what they do is when when they get an error, like when they get a compilation error or runtime error, they feed all that straight back into the LLM,
Hmm.
have it improve the result, and then they run it again, right?
So stuff
So
like this is really helpful. Like,
exactly because the
by the way,
LLM
it should be
can
one of these two, and the LLM
exactly
could take a hint. Yeah.
or regularly you'll see that these LLMs will hallucinate inputs that are similar to the examples that you've provided but like are like a logical extension, right? So like for like a weather one, the rather than a location string, it might think, well, I can probably have pass like city, state, and zip code as parameters, right? And it's just doing that because like maybe that's a lot of weather APIs have those parameters, right? Um, so when you can create this feedback loop to say, no, you probably meant location, right? Um, like or like that's an invalid parameter, use this one, or that's an invalid option, use these. It's able to like
Yeah.
heal itself
To be
and
honest
create a
with you,
better
you're describing my coding process.
exactly right. It's exactly how a
I
human would do it.
mean, like this is what I do, like, and so yeah, I think like given that like with all like if this AI use case, you want the same thing, it would be really nice to do.
It is nice with LLM programming because it turns out that a lot of your asks end up being the same things that people would want. So yeah, good
Yeah,
synergy.
yeah. Hmm. Yeah, and the descriptions too. Like for example, for the Lua step, the descriptions could say script is a valid Lua script. And an LLM may be able to be like, oh, I know what a valid Lua script is. So I'm going to try to make a valid Lua script here,
Exactly. And
which could be
actually
very helpful.
if you want to poke into that GitLab script step that I wrote,
Mm.
go up to I think it's the step YAML.
Mm.
And
Oh,
I had to
nice.
comment these out because they are not valid. They make StepRunner complain. at the moment, but this is exactly what I
I
was.
thought we had this. We're supposed to have this. I thought we had this. I'll put it there for you.
Okay, yeah. And yeah, well, I was confused. This is a good time for me to ask, what is the
Hmm.
expected syntax for the outputs at the moment? I know they're all strings, but can they be specified in this way?
Can't remember. I'll have to go look.
Okay,
I used to have outputs in the previous implementation. We will have outputs, and they should also, I think right now they won't have a type unless till we get to the more structured ones. But like, yeah, we should definitely have outputs declared. And we should only output the outputs that are declared, I
agreed.
think.
Yeah. I think that makes sense.
I think globals will let you export whatever you want. Just like you can put in whatever you want for globals. It's just like your escape hatch
Is that in like
for
environment variables?
environment variables. Yeah, yeah.
Okay, okay.
So like the environment variables, will just be made available from the larger that's how you get some of the stuff sort of implicitly into steps. And then exports, anything you export, we'll just go ahead and accept. You don't have to pre-declare it.
Yeah,
Um,
that makes sense.
but we should
Um,
definitely lean towards inputs and outputs as with all the documentation and best practices.
yeah,
I feel like there's a few interesting tricky things with outputs. One of the places I did put outputs not in the spec, but actually in both places was for type steps. Because when you have a series of steps, you still need to make an outputs that represent all of those together. So
right.
you can put an output block here and pull things from the various step outputs, the sub-step outputs, in order to like produce the outputs that you declare up here. I'm pretty sure that you can declare outputs. I'm pretty sure that this is okay to do because I did implement outputs down here as well.
Okay, I'll take a look because this is like an area that I was thinking might be a good like first contribution for me, just
Hmm.
because I can kind of familiarize myself with the code base at the same time. Um,
Hmm.
it did seem like it accepted uh the
Yeah.
output keyword, but when I certain properties that I would declare would make it not work. It seemed like, but
This
yeah,
is this is this is
this is
definitely a
exactly
valid step. So for example, here, I want the two outputs, I want to grab them from, my internal implementation details here, and I need to declare them here as well. Um,
that this is actually exactly what I was expecting and hoping to see, that it would be defined in both places, that you'd have an area to define the schema and then you'd have an area to define the mappings between.
yep.
Yeah, yeah,
Yep. So it's there. It's there
cool.
for sure. Cool. Yeah. Anything else we want to hit before we close? Oh, by the way, Nest, we just haven't done this yet. Um, we had a few different ideas for how to do this. But we'll get around to it because of course you want to be able to put more than one step in a repo.
Okay, cool. Yeah.
Yeah.
um and then similar, like the tolerant parsing of remote URIs. um like I
Mm,
it was kind of annoying that it had to be specifically like a valid Git remote URI. It'd be
I
nice if
think
it could just be.
we might do a lot of that as part of the sugar transformation. Like
That
we'll
makes
be,
sense.
yeah, because we want to kind of like have that really simple core. Um, I was wondering if you could think a little bit about what you want the gRPC interface to be. Um, what we have right now is a series of idempotent APIs. Create a job, you give it a job, like some ID, a set of steps, and then follow, and probably also follow IO, because following to get the structured response is going to have a different access pattern from following standard in and standard out. And they go different places, and standard in and standard out is going to be unbounded. So we have to treat it a little differently. And then we also have cancel. So I don't know if those work for you or not.
Yeah, I hadn't thought in detail about what the like execution API would look like. I was imagining that you could have like a single interface that would have messages. I mean, streaming standard in, standard out is kind of a hard, like,
You might not want that. Like you might want to just throw that away.
yeah, yeah. Well, I think
Yeah.
at the very least, like what I thought what you were saying is that like you probably want an interface that only returns structured data. If you want like the standard in, standard out, like maybe you get that separately, like subscribe to it separately or something. But I think for our use case, what's most important is just streaming the structured results, right? So after each step execution, returning the payload for.
Yeah. Cool. So I'll send you this merge request if you want to just kind of like throw your opinion in there about what you want. It would be helpful for us to figure out what to do because we're at the point now where we're about to write some details in the blueprint, and we'll show that to you too because it would be really nice to incorporate your use case in this and just plan for it from the outset.
Okay.
Like for example, Axel created a well-behaved client and wrapped all those with just something that does basically what you're describing. Just you just give it the thing and it gives you the results. You don't have to deal with all the in between API calls. So
And like, were you saying you like the current interface? You get like a job AP or a job ID, and then you can follow the trace basically by giving it
hmm
back the job ID.
hmm.
Okay.
And in order to support Runner, there's probably going to be also a list API that you can go to Step Runner and could just ask it, what are you doing right now?
Mm-hmm.
Which would allow us to make Runner stateless. So Runner can reboot, forget entirely what it's doing, discover the instance group that it's managing through its configuration, find the instances, contact all those step runners, and just ask what it's up to. And
Mm-hmm.
then just kind of backfill all of its state from those step runners, including the job token, and pick up where it left off, which is a really nice thing for reliability and scalability as well.
Mm-hmm. That makes sense. Yeah, it's the it threw me off that you would need the I like I've just been thinking of Step Runner as like a single execution, right? Like you just throw
Yeah.
stuff at it and
Yeah,
evaluate
it's
and
not
it
at all
shuts
your
down.
use case. You won't probably won't care about the list API because your thing is like on one machine, right? Like it's very reliable.
Yeah, I think so, but it's interesting to think about. And what can you shed some light really quick on do we actually have use cases defined where Step Runner would be persistent beyond multiple job invocation or beyond a single job invocation?
hmm hmm. Yeah, like our private runners, or any time that you configure runner with max use count greater than one, and concurrency greater than one, two. I mean, like concurrency or like whether they're not they're sequential. We'll fire up a VM and it'll have a daemon, step runner daemon that starts up. And it's going to have multiple callers, like
Okay.
create this job, interleaved. Um, and each one of those is going to be operating in a different directory.
Uh-huh. Okay. Okay. That's interesting. So yeah. So like instead of like starting multiple like Docker machine instances like we kind of do today for parallel jobs, the idea is that we spin up a single VM with one step runner interface, and it can then potentially orchestrate multiple concurrent jobs on a single VM, stuff
Mhm.
like that.
And a
Okay.
lot of that is up to how you want to set up the execution environment. And this is specifically not step runner's job. That's what
Okay.
my goal is to make runner just about creating and routing, jobs to execution environments, like pods, VMs, containers, whatever. So yeah, that'll be part of the life cycle of those execution environments.
Cool. I appreciate you taking the time. I know we went way over, but I think it's
Yeah, we
valuable.
blew it away. But yeah, it was really nice to catch up on this. And let's stay close in our communication because I want to keep this as a primary use case for step running for sure.
Cool. I'll start by trying to make some contributions to the inputs, outputs, and go from there.
Okay, cool. Thanks.
Cool. Have a good one.
Bye.